Good morning, everyone. A warm welcome to the chair, the keynote speakers, paper and poster presenters, and dear participants. I, Sakshi Pandey, Assistant Professor at Amity Institute of Information Technology, Amity University, Patna. I'll be your moderator for this session on defense informatics and military applications under day 2 track 5 session. This session focuses on how artificial intelligence, data analytics, and emerging technologies are transforming defense, military operations, and strategic decision makings. Now, I would like to introduce our chair for this session, Dr. Diwakar Tripathi, Assistant Professor at NIT Jamshedpur. He has been actively engaged in research and teaching in the area of computer science, contributing to several reputed journals and conferences. Now, I'm delighted to welcome our keynote speakers for today's session. Our first keynote speaker is Professor Manju Khari, professor in the School of Computer and System Science at JNU, New Delhi. Her research interest includes information security, artificial intelligence, IoT, and cyber forensics. She will deliver her talk on deep learning and its research challenges in current scenario. Manju ma'am, welcome, and over to you, ma'am.
Thank you so much. Thanks a lot. And thank you for the organizers to invite me here for the session. And it was really a pleasure for me to be a part of your conference. So we have papers to present, right, at this moment. So as far as the conference is concerned, we are actually grabbing the new ideas, new concepts. So all the best to the presenters. Let us begin with the presentation. Thank you. I can't listen anything.
Ma'am, we are waiting for your talk on deep learning and its research challenges in current scenario.
Right now.
Yeah.
Oh, I have to connect my laptop then. I'm so sorry.
So, ma'am, can we continue with
Yeah,
with our
we will.
next speaker?
Yeah, please. Thank you so much. After that, I'll connect. Yeah,
Okay.
thank you.
Okay, ma'am. So our next key speaker is Dr. Roshan Singh, Assistant Professor in the Department of Computer Science and Engineering at IIIT Ranchi. His specialization area include artificial intelligence, machine learning, deep learning, computer vision, and image processing. He will be speaking on ML Ops, bridging the gap between data science and production. Roshan sir, am I audible to you?
Yes, madam. Good morning.
Yes, sir. Welcome, sir, and over to you, Roshan sir.
Okay, good morning, Dr. Sakshi, and thank you, Dr. The organizer of this event, Dr. Sushant Pandey, for inviting me to this conference. So I will be presenting my topic on MLOps. So I'm sharing my slide. Okay, so my screen is it visible?
Yes, sir. It is visible.
Okay. Well, so I am presenting my topic on MLOps, that is machine learning operations. So we will understand in this presentation that why machine learning operation is required in deploying a machine learning models. So how we can bridge a gap between a data science and the production. So first of all, we will understand what is the gap between data science and operations team, that is production. For this, first of all, we will start with understanding that what is ML and what is a ML system. Actually, this is, let me change this view. Yes, okay. Is creating this view. Okay, minimize. Okay. So if we see a machine learning system, there are a lot of components that creates a machine learning system. Like there will be data collection module, there can be analysis tools, there are monitoring, configuration tools, data verification, and machine learning resource management. There are serving infrastructure, there is deployment infrastructure, process management tools, feature extraction tool, and machine learning code. If we see these all infrastructure components, we can see that machine learning code is a very little part of the whole infrastructure. So we can say that a machine learning system is built of a very complex infrastructure that is very vast and huge. So in order to deploy a machine learning model with current practices, we face several difficulties. Like I ran an experiment but did not get the same result. Can you check my way of running the experiment? This is there is a problem of reproducibility of the result in machine learning operation, because machine learning models provides you can say the outcome of machine learning model or inference results of machine learning models depends on various factors. Like there can be data set with different version of data set, there can be different version of codes and different version of tools that you are using. They all can impact of machine learning model. So if I am running a machine learning one the other did not work, are you sure you installed on several type of packages, several different tools with different versions? So it may be the case that the development team build the code and run it very successfully, and model was running properly. But when it is handed over to the deployment team, in many cases, the machine learning model that was developed in the development team fails to properly deploy in the development. So this is the problem of portability of the machine learning models. Next is that I'm sure that my changes really help the model performance. Hope it still works in production. Okay. So machine learning models very frequently evaluate. It keeps on evaluating with the time as the data, that input data changes, and there can be different features that can be changed in the model, and thus there are a lot of versions of the model created during the development of the machine learning model. So it becomes very difficult to track the model which gave the best performance or which gave the best result. So tracking of machine learning models that that helps best in the production is very difficult. So this is also a challenge for machine learning engineers. Next is that is your model available in production? Can I use it with my mobile application or website? So how can I do so? The next challenge is once you have created the model, you have to deploy it, and it should be very efficiently and quickly deployable. But many times the model that was developed by the development team, if you are going to deploy on the machine on the on the deployment in the production, it fails, and it becomes a very challenging task and very time taking task, the deployment of that trained models. A data scientist builds a model with 95% accuracy in a notebook, and but when it is deployed, it fails to deliver the same result in production. In many cases, it has been found. And if you are following the traditional model, and many ML projects never reaches the production. A report says that very less, that is less than 20% of models only that are built in the production that are actually deployed in the operations. So, what is the usual workflow that we follow? In usual workflow, generally, each member of the team manage their own code base, their own data set, and their own models. Okay, so there may be that some team has other version of the code. Either, some member of the team has other version of code. Some member of the team has other version of code. So reproducibility of the model creation is difficult, and it cannot guarantee over the time. So since everyone is having different version of code, and there may be the case chances that he has also different version of data, and it is hard to synchronize their works. Then improvement made to the model are hard to track also, since we are creating different models. There were several models are generated during the experiment, and those models may vary based on the input data, on the version of code, on version of data. They have different results. So it is very hard to track the models that which model gave the best results. So if you follow usual machine learning framework, it is very difficult. Then models are hard to share and deploy in production. Yes, if we are building a model on one machine independently, and if we are providing it to a deployment team, it is very hard while using the usual machine learning workflow. So if you are using this normal machine learning flow, it is flexible. Yes, you have everyone is doing independently work. It is flexible, but it is very hard to maintain, hard to reproduce in future, and it is very time consuming. So yes, we can do better than this by following the machine learning operations, ML ops processes. So ML ops is drawn inspiration from the software and DevOps best practices. Okay, so we adapting these practices to the machine learning, to the world of machine learning, we can improve the management and quality of machine learning projects. ML ops consist of, you can say, machine learning along with the DevOps feature plus data engineering. This combined process can be treated as machine learning operations, ML ops. The goal is to automate and standardize the ML lifecycle, bridge the gap between data science and operations, then improve the reproducibility, collaboration, and scalability. So how can you begin? Suppose you have just joined a team of data scientists and machine learning engineers. The team is working on a model capable of usually identifying planets and or moons with our solar system from image in a Jupyter notebook. The team is facing difficulties to move the model to production. Your mission is to help the team to improve the model using ML ops best practices. Okay. So if you look to a broader picture, we can see for developing this project or any project, we will have a code base. Code base means we will having the ML codes for the whole processes, different process like data have process feature engineering. Then you will have data that is being used as input, like output files. Then there will be you must be aware about Git. So Git can be used for maintaining different versions. Further, we can sync our code to some cloud like GitHub or Bitbucket. You can sync your code to that, and you can work with your team in a collaborative manner. You can push your code from your local system to remote GitHub repository, and the team that is working on this project can simultaneously work and simultaneously access the code, the changes that is made by one member. So this is a very good tool for version control of the code. we can use this Git and GitHub in combination so that we can maintain the version. If one code is not properly working properly, we can switch to previous versions of the code. So this is used for version control. Next is data and reproducing it. So data is other important part of the machine learning model, where we give the input. That input can be drawn from your local machine, or it can be drawn from some cloud like AWS, or you can use Google Cloud. So you can have data from Google Drive also. So accessing the data from some source and maintaining the version of that data and reproducing it whenever required, whenever we want to change, we want to check different models. So DBC, that is data version control tool. This is a tool that can version of code also. So this can be also used as a version control tool for the data. Other part is that tracking. How can we track the different experiments? That what was the different model outcomes on the basis on different data versions, different code versions. So we can use tracking tools like DBC, and we can use CML for continuous machine learning. Yes, like maintaining the CI/CD pipeline. And uh, apart from DBC, we can also use like MLflow is also a very good tool for managing the tracking. So we can use DBC or MLflow for tracking the experiments. MLflow also provides the option for registering your models that has been generated by the machine learning applications like GitHub, or like by previous processes of the machine learning model. So we can also register the model in different stages, like staging, then testing, staging and production. Different labeling can be done in MLflow. So these are different tools that can be used for tracking. Then comes the serving and publishing of that complete model. So for serving, there are several tools that can be used. Like one I have mentioned here is Bento ML, or Docker can be used for publishing the complete ML model along with all its dependencies. And this is one process that is followed in ML operations. So next is the storage. For storage, we can use any cloud infrastructure like Google Cloud or AWS. So levelization is other part that is very important in machine learning operations, that the data changes with time, and machine learning models inference majorly depends on the data quality of data. So when the data changes, it should be quickly labeled and provided. It should be available for training. So levelization, Level Studio can be used for that for automatic AI-based labeling and and management of the data, management of these pipelines. This is orchestration tool. Of the model, we can use in the code is difficult. So we machine learning, using a machine learning operation, we can improve we can improve the code sharing of code base, and we can share the common code to all the team members. In data, we can see that the data must be manually downloaded and put in the right place in current scenario. Different data sets are being used at the same time, so data sets are hard to improve. In using DVC, we can allow the usage of common and up-to-date data sets, and efficiently share the new revision of trained model to the all members of the team. Data set can be stored anywhere, and it can be accessed by the DVC framework. Then if we talk about reprioritizing to track from one run to another. Difficult to track and visualize. The differences are hard. Cannot guarantee the changes are beneficial. Using these DVC and ML flow tools, we can easily track and visualize the changes in different runs of the project. And finally, serving and publishing of the model can be is in current context is very difficult, but using tools like BentoML and Docker, we can easily serve the model and finally publish the model for further deployment. And in deployment, yes, if then experiment can run on machine, but it can fail. But if you are using a machine learning process, MLOps processes, then it is very easy to deploy a published model in Docker to a Kubernetes framework. It is very easy. We can easily deploy the model seamlessly from a development team to a deployment. So the same as labeling, we can use like Label Studio to AI-based inference system that can be used for labeling the process. So in conclusion, we can say that MLOps process can improve the management and quality of machine learning projects. And we will be able to switch from a Jupyter notebook to production using state-of-the-art ML tool. And we can go from experiment to production on cloud using best practices of ML. So this is all about MLOps. These are some tools, some alternate tools that I discussed for different purposes that we have used. So thank you. Thank you very much. Hello.
Yes, sir. Thank you so much, Roshan,
Yes, sir.
for your valuable insights into ML OOPS and its practical implementation in deploying AI systems. Is there any questions from the audience? Okay. Thank you so much, sir. Roshan, sir. Thank you so much. Can you hear us, Roshan, sir? Can you hear us?
Thank you. Thank you very much.
Thank you, sir. Yeah, thank you so much. Next, Manju ma'am, I just wanted to take a confirmation from you. Are you available right now for the presentation? I think she hasn't joined yet. Now we move to the paper presentation segments. As we know, each presentation will get 5 minutes for presentation, followed by 2 minutes for question answer session. Kindly ensure you stick to the allotted time. I would now like to invite our first paper presenter, Vishal, on the topic AI-driven decision intelligence, bridging business analytics and defense technology.
Hello. Hello. Yes, ma'am. I'm Dr. Divakar Tripathi.
Yeah, sir.
Ma'am, is there any evaluation sheet for it?
Pardon me, sir.
Is there any evaluation sheet for the whatever the presentations are going on?
No, sir. No, sir.
Okay.
Thank you, sir.
So, shall I have to give some
Yes, sir. Yes, sir.
feedback for it?
Yeah, yes, sir.
How Then how can I give the
No,
feedback?
sir, you can ask questions from the presenters.
Okay.
Yeah, that's it, sir.
Okay.
Yes, sir. Vishal, can you hear me?
Yes, ma'am. I'm audible, ma'am.
Yes, you're audible. Give me a second. Share. Vishal, can you share your presentation?
Yeah, sure. Just a minute, ma'am.
Mr. Vishal, are you allowed to share your screen?
Yeah.
Okay.
Yeah, is it visible?
Yeah. Yes, it is visible.
Yeah, very good morning to all the dignitaries. My name is Vishal Patel, and today I'm going to present my research paper topic, that is AI-driven decision intelligence, bridging business analytics and defense technologies. So first of all, let us start with the introduction or abstract. So as you can see, this presentation explores the integration of AI-driven decision intelligence within business analytics and defense systems. So it highlights how data, machine learning, and cognitive technologies enhance decision making, precision, and strategic foresight. Next is motivation and research background. So, if we talk about business and defense sectors, they are facing uh, growing complexity and uncertainty. So, as AI-driven decision intelligence bridges analytical rigor with real-time adaptability to improve strategic outcomes and operation resilience. Next is evolution of artificial intelligence in business and defense. So as we know that AI has evolved from rule-based systems to self-learning models. Then if we talk about in business, AI supports forecasting and optimization. And in defense, it enables threat protection, border surveillance, and you can say autonomous systems. The next is integration of business intelligence and defense applications. So, if we talk about AI applications in business and defense, then in business we can say it is used for market analytics and customer insights. And if we talk about defense, so as we know that in defense AI will be used, can be used to situational awareness, mission planning, and for the border security. The next is data-driven decision support systems. So data-driven decision support system integrates structured and unstructured data for rapid analysis. These systems enable predictive situational assessment, risk mitigation, and optimal decision outcomes. Then next is AI in defense strategy and operations. So artificial intelligence supports command control system, logistics, cybersecurity, and mission planning. Then autonomous decision engines helps in faster response and tactical accuracy. So next is ethical and security consideration. So in ethical and security applications, they must address the bias accountability, transparency, and national security applications, or you can say implications. Ethical framework and AI governance ensures responsible innovation. Then there is a comparative analysis between business versus defense, that how business in business and defense AI can be used. So if we talk about business, so in business AI can be used, that can be focused on profitability. Then we can say it is used for the increasing of efficiency and also for our customer satisfactions. Then if we talk about defense, so in defense, AI focuses on safety, precision, and tactical, you can say, advantages. Then there are, I have discussed two case studies. Case study one is related with AI-enabled tactical decision systems. So in this, autonomous decision support tools analyze battlefield data and recommend real-time strategies, improving operational agility and reducing human errors. Then the case study two is focuses on predictive maintenance in defense equipments. So predictive analytics monitor equipment health, forecast failures, and schedule maintenance, reducing downtime and its operational cost. Then what are the different benefits and challenges? So if we talk about benefits of AI in defense or business sector, so benefits are it enhances the accuracy. Also, we can say it enhances the speed, increases the speed, adaptability, and increases the scalability. And if we talk about challenges are you can say uh, data, we can say that is data security, then ethical governance, interoperability, and some algorithm biases are challenges in this area. Then last is some quantitative evaluations and results. So comparative matrices across sectors shows improved efficiency starting from 20 to 40%. And if we talk about accuracy, so it is up to 35% in the current scenario right now for decision-making systems using AI-driven decision intelligence. Then final we have conclusion and the future scope. So AI-driven decision intelligence stands at the frontier of the interdisciplinary innovation that is merging analytical precision with strategic foresights. So future research, you can say, may explore simulation-based validation and AI governance and cross-domain adaptability. So these are the some references. So this is all my PPT related to my research topic. So any questions? I think I adhere the time that is 5 minutes
Yeah.
for the presentation.
Yes. Any question from the audience?
Am I audible, ma'am?
Yeah, you're audible. Any question from audience? Or you can type your question to the chat section as well.
Okay, sir, tell me, what is your contribution?
Sorry, sir.
What is your contribution in this particular work? Whatever the things you have presented here, so I didn't see any contributions here, sir. Either that is some review type of thing, or your contribution, you have developed certain models for validating something. The thing is missing here, sir. Yes, just like you are talking about it, like machine learning is working for the predictive analysis, for the fault tolerance support system, and something. But what exactly methodology they had adopted and how exactly the things are working? That is missing.
Mr. Vishal, can you hear us? Divakar sir, it seems there's a network issue. Now, moving forward, I just wanted to take a confirmation from Manju Khare ma'am. Ma'am, are you available for the presentation?
Yes, I'm available for the presentation.
Yeah, ma'am. Welcome, ma'am. And I just want to introduce one more time to our distinguished keynote speaker,
Thank you.
Professor Manju Khare ma'am, professor in the School of Computer and Science Computer and System Science at JNU New Delhi. Her research interest includes information security, artificial intelligence, IoT, and cyber forensic. She will deliver her talk on deep learning and its research challenges in current scenario. Welcome, ma'am, and over to you.
Thank you so much. Thank you so much. Just to inquire, the previous Vishal presentation was the paper presentation
Yeah.
or something? Okay, okay,
Yes,
okay.
ma'am.
That was I'm so sorry for the delay. Maybe because the keynote should be in at the first, and then the paper presentation should be continued by that. Okay, as far as thank you for the introduction, Sakshi. So as far as my topic is concerned, I'm going to talk to you in terms of deep learning. What are the latest trends which are going on? And as far as the latest trend is concerned, for the future researcher, it was like every researcher is working in machine learning, and nowadays every researcher is switched to deep learning automatically, and they are picking the deep learning because it is a part of, or it is a version of machine learning. It is or we can say enhanced version deep learning. So every researcher is digging deep learning and coming up with some outcomes, some predictions, and on the basis of parameter they are giving some predictions. So I'm just going to tell you what are the more research zone areas where the researchers can work in terms of their applicability. So this is just a basic thing which I'm going to cover, and I know now everyone knows about what is artificial intelligence, what is machine learning, and what are the basic concept. But because as the time allows me, it is of 10 minutes, I guess. So let me brief you about, or I'll just recall you about what exactly artificial intelligence is. It is nothing but a machine. We make machine intelligence with intelligent with feeding some algorithms into it. And if we look in a broader way, it was we have input, we have intelligence algorithm, and we have output. So artificial intelligence basically come with a intelligent algorithms. And if we talk about machine learning, we have number of algorithms in machine learning, and we put machine learning algorithms after data. It may be labeled data, it may be unlabeled data, and then we design algorithm, machine learning algorithm, which is actually an intelligent algorithm, and then we create a model and then come up with predictions. So there is very like all are related to each other. And if I'll show you the diagram, it is like machine learning intelligence is a broader part, then machine learning comes into it, and deep learning is actually a subset of artificial intelligence and machine learning. So this is a broader view. And as we know that we are dealing with sensors, we are dealing with devices, and we are dealing with number of applications. Everywhere there is intelligence, everywhere there is something which machine is learning and giving us the output. So in terms of research, if I can say, deep learning, how it is different, because in machine learning or a rule based system, we have only input, algorithms, and then output. But slowly, gradually, as we are enhancing machine learning algorithm, we are putting or adding more features into it and moving towards deep learning. But as far as deep learning is concerned, it include more things into it, more features, more add-on we can say add-on functions, and then we come up with some outcome. Deep means digging deep and getting some outputs. So if we look a broader process of deep learning, the first and foremost thing is that is similar to machine learning, but the only thing is digging more into the data and into, or going deep for the algorithm, coming up with more layers, more features, more constraints, more rules that comes with deep learning. So initially we have to understand the problem, what exactly the problem is. Then we have to train the algorithm with data, and once we train the algorithm with data, the relevant data which we pick, we have to identify the relevant data. Then we have to analyze the data. Once we analyze the data, then we have to apply the algorithm onto it, and then we have to map it like algorithm and data. We have to train them, and after training we have to do the testing. This is the normal generic process, but in deep learning we do more digging way. And every data analyst, every scientist, every researcher when they deal with deep learning, they dig more, they come up with huge amount of data, because deep means they consider a huge amount. In machine learning we have small amount of data and then we come up with predictions, but in deep learning we have a huge amount of data, and algorithms are also very filtered with more features, and then they give some outcomes. So as far the evolution of deep learning is concerned, initially the concept comes into the research market in 1958, and slowly gradually many algorithms comes into the picture in terms of research. We have convolutional neural network in 1998, we have lxnet in 2012. Then slowly gradually things are coming. We now we are in model scenario, like we have lstm, we have llms nowadays. All are completely based on the learning approaches, and once we train the system, they learn, and they after that they provide us the output accordingly. And if we look into the research, this is one research. With the help of machine learning, initially they pick the image as an input, they classify it, then the detection is done, and the segmentation is done. But this is all about in terms of research, because they have various algorithm. Researcher apply algorithm for classification, and then they come up with a with some output which classify that image. Then for detection also they apply algorithm into it, which is machine learning algorithm or maybe deep learning algorithm. And after that they provide the segmentation with in terms of output. This is one research. And this is another research for object detection. They have an image, they detect the object, and they provide the emotions which are there in the image. This is one research. Then this is an activity, images are provided to the system, and then machine predict that which activity it is. So this is also one research. The researchers has to design an algorithm. It is something like that. They design algorithm, and at the end they predict the activity which is there in the image. Then we have semantic segmentation, clearly specifying what exactly there in the image. Then this is the pneumonia detection prediction. With the help of X-ray image, they detect how much pneumonia is there in the image, and then provide the predictions. This is image colorization. It looks very simple. They provide input and something which is executing behind this or in the machine, and then some prediction is coming in terms of image, in terms of output, or in terms of values or prediction. So this is, but the main core work is with the algorithm. We have to design algorithm which can at least fulfill the objective which we are looking for. Their learning plays a very important role. Deep learning algorithm, machine learning algorithms plays a very important role over there. Then this is a photo realistic stylish transfer. The input original image is something else which is there on the screen. The first two images are the original image. The reference images are at the second row, and then we have the results. Like they have few photographs. With the help of the reference, they create a new image. The algorithm create a new image. This is something enhancing an image, and we can enhance the image with the removal of the background, and that is done with the help of algorithm. Then this is creating a complete image. If image is disturbed, then they create a complete image, or removal of an object from the image that we all have in our smart devices nowadays. So behind that application, we have these kind of algorithms which are running. Then image completion example, the image is discarded, or image is disturbed, and then the image is created with the help of algorithms. Then this is something, we have number of applications where we are using input in terms of images, but videos are also a collection of images. So this is one research which is learning lip synchronization from the audio, and this is also one of the research which actually help the researcher to create an audio or create a text from the audio. Then this is just a let me go to what is the research available nowadays in for future researcher. As far as text processing is concerned, as far as natural languages is concerned, we have number of things or number of tasks which we can do as a researcher in terms of research, in terms of for classification, because we have the objective of language detection, we have objective of topic detection, we have also objective of positive and negative sentiment analysis detection that we can do for text processing with the help of deep learning. Then we have fact extraction, so that people can extract the fact from the images as well as from the videos. Then we have language models, part of speech recognition. These are also few objectives which we can include in our research and come up with some good learning algorithms. Then we have key phasing extraction only in terms of text processing and natural language processing. We can do searching better, we can do the work on question answering and dialogue system in terms of text processing. And these are just example for text processing and text generation. Then we still have too many problems with text, images and multimodal learning, and for their deep learning model become, usually nowadays researchers are claiming that deep learning model as becoming multi-models, because multiple objective, multiple algorithms and multiple outcomes. So there we have option with image generation, with search web by an image, or video describing we can also do in terms of for research in text, image and multimodal learning. Then we have speech recognition, audio and video with lip movement, and for colorization also. Then if we look into the more research we have in terms of security and AI, we have expansion of existing threats, because number of threats or number of viruses are coming into the cyber world, and all the viruses are also coming with learning aspects, because initially we have viruses which are coming with with one pattern, but nowadays viruses are coming with different patterns. One click maybe they corrupt your file, one click maybe they corrupt your window, or because they are also coming with learning approaches, they are also coming with add-on tag with intelligence. But as far as researchers is concerned, we can design few tools so that they can predict the pattern of the viruses, of the threats, or whomsoever virus is coming. If they have learning approach, if they have learning aspect, then at least any algorithm, any new or novel algorithm can detect that pattern. So there is also a scope in research in AI with security. We can predict the attacks, we can predict the patterns before before attack can corrupt the network, and more research is there. But in terms of data, in terms of algorithms, in terms of, or if we combine all of them, the major role played by data, and the data, with the help of data, with the help of training and testing the data, we create model. So if we don't have data sets, then there is no concept of working on deep learning. And while working with deep learning algorithm, make sure that whatever data you are picking, that should be the authentic data, because if data is not authentic, your research will be have no validity, or the research is waste almost. So pick the data from the authentic sources or the benchmark data, then apply algorithms into it, and then do your research for better outcome. These are few data sets which are freely available, and the license and the benchmark data set, you can pick the data set. If you are working in image data set, these are few data sets. If you're working in speech data set, these are the list of data set. If you're working in text processing, then these are the few data sets. Now for natural language processing also, there are list of data sets, and for geospectral, these are the few data set which you can pick and apply your research and algorithm into it, and then do the predictions. As far as importance of data set is concerned, we have number of data sets which are available in research market. But dataset after dataset, we need a framework where we can apply the algorithms and learning approaches, and we come up with some predictions. Majorly, researchers are using TensorFlow and PyTorch. Why TensorFlow and PyTorch? Because they usually give good prediction. As far as PyTorch is concerned, maybe the user interface was not that much good, but the TensorFlow have a good interface, so that the researcher can at least view what kind of result they can get. So these are few data deep learning libraries which researchers can use for the predictions. Although they all are free, but they are like, you can get the license version also for good research. And these are the link through which at least you can recognize how we can deploy these deep learning models for our for the future research. And as far as application is concerned, these are the applications where we can use deep learning, we can use artificial intelligence to make our environment more intelligent and more smart. Like likewise, we have self-learning driving cars, where we can apply learning algorithms. We have news, because fake news are spreading here and there. How to detect that fake news is coming into the market? How we can detect that fake news is the original or the fake? We need to research on that. Then natural language processing, because we discussed too many things about text, and natural language processing is also one of the application where we apply machine learning, deep learning algorithms. Then we have image search system, we have personalized, we all want personalization, we all want everything to be personalized for an individual. There we can use these algorithms for entertainment, for visual recognition, and as well as for healthcare also. But the latest trends which are there in 2024 is, because AI, after COVID, AI plays a very important role in our life to detect our blood pressure, to detect diabetic, to detect too many things in our health, to detect our footstep. So that is a concern. As well as for researcher, it is also an open invitation that we can work in AI, which is helping in healthcare system, and we come up with some new approaches. Then the framework competition is also a big research where number of frameworks are coming with their good features. Any researcher can design a new framework like we have 10 to 15 which are in a competition. If any researcher want to do good research, they can come up with the novel framework, ML framework, which support like these framework which are available in research market. Then analysis as for business forecasting or reinforcement learning is also an upcoming term, we can say, because we need feedback, and reinforcement learning provide us feedback for the work which we are doing. Then we have AI driven biometric solutions, so that they can, we have in our phone, right? We need a complete system to be biometric, so that once a person enter, automatically it get attendance or it get scanned and everything. No need to waste time on gates and the scanners. So that is also a research need nowadays. Then machine learning, it is automated, but we come up with new or more faster automation in machine learning. Explainable AI is also required, so that every AI can explain why they are doing this kind of why they are coming up with this kind of prediction. Then we have generative network, and as far as IoT is concerned, because we all are living in sensor world, so that IoT and AI is also the major trend which is impacting research and our social life too. So that's it from my side as far as the latest trend and research is concerned. So if any questions, then please let me know.
Any questions from the audience?
So no questions, not a problem. This is my email ID. If anyone want to contact with me and do research in AI and machine learning in terms of security, then please contact me, or for the internship, or for future research guidance. I'll be happy to work with you all. All the best.
Thank you. Thank you so much, ma'am. Thank you so much for your time and for sharing your insightful perspective on deep learning and its evolving challenges. Thank you, ma'am. Next, we move ahead with our next poster presenter, our next participant, Prashant Kumar and Ayush Ranjan. The topic is leveraging AI and data analytics for strategic decision making. Video.
Good morning, everyone. I am Ayush Ranjan.
And I am Prashant Kumar.
From AIT department, and today we are here to present my poster on defense informatics and military applications. In today's world, the defense sector depends on lots of technology. Every day, a huge amount of data is collected from satellites, sensors, and surveillance cameras. To manage this data properly helps the military make faster and better decisions during missions. Our project focuses on how AI and data analytics can be used to improve defense system. By using an AI-based defense decision support system, we can predict threats more accurately, plan mission more effectively, and respond quickly in critical situations. And I pass it over to Prashant.
The main goal of our today's study is to build a smart and secure digital defense system that handles cyber threats, manage large amount of data, and help protect the nation from efficiency. As per given in the poster, we can predict the cyber threats, mission adaptability by using the impact of AI-driven defense system. Thank you.
If anyone have questions, please ask. Thank you, everyone.
Thank you so much, Prashant and Ayush. Our next presenter is Prince Kumar on the topic AI-powered battlefield decision support system for modern warfare. He's not with us. Okay. Our next presenter is Prince Kumar. Arav Pal. Our next presenter is Arav Pal on the topic Strategic Intelligence 2040, a conceptual framework for centralizing AI in defense and security operations. Arav, please join us.
Morning, everyone. I'm Arav Pal from MIT University, Patna. In the next 5 minutes, I'm going to outline one of the most severe threats to our modern defense infrastructure, data poisoning, and present a clear, verifiable solution called the dial integrity loop. Before we detail the threat, let's frame the stakes. The use of AI in defense present a fundamental trade-off. On one side, the advantage is speed and scale. Autonomous system offers faster threat analysis and a decisive edge in rapidly changing environment. On the other side is the enormous risk of unintended consequences. A single corrupted data point can lead to catastrophic miscalculation and accidental escalation and strategic failure. Our goal is to maximize the advantages while creating a verifiable and technical mechanism to manage the critical risks. The central threat is that corrupted data lead to catastrophic decisions. The slide shows the attack chain. It starts with clean data input, reliable sensors and intelligence feeds, but an attacker finds an poison infection node and inserts flawed manipulated data into the pipeline. This compromised data feeds the AI, leading to compromised output, false threat evaluations, and degraded decision making. The end result is strategic escalation, where our own misguided response escalates a crisis, risking unintended conflicts. The core of the problem is a dangerous gap. On one side, we have policy. Ethical framework mandates that our AI must be reliable, robust, and transparent. On the other side, we have platforms like autonomous UCAVs. The systems are technically vulnerable because the verifiable mechanism to enforce those ethical rules simply doesn't exist. We have the what, but lack the technical how. Closing the gap is critical. Our solution is the dial integrity loop. It's a continuous architecture that translates ethics into trustworthy autonomy. It's built on 3 layers. Layer 1 is the ethical mandate layer, which defines the high-level principles. Layer 2 is the technical implementation layer, which translates those principles into auditable technical steps to ensure data integrity. Then this leads to layer 3, the autonomous decision layer, which executes its mission based on those verified input, creating a secure and auditable feedback loop. Diving into layer 1, security must start at the source. We must secure every single data entry. We can do this by creating immutable data trails using cryptographic hashes and timestamps. We log every piece of intelligence the moment it entered. This process creates a complete tamper-proof record. It prevents data corruption at the source and enables retrospective verifiability. We can trust the data because we can prove it has never been altered. Next, in layer 2, we monitor the AI in real time. We use an AI tripwire. While the primary AI is executing its core functions, the tripwire runs in parallel. Its only job is to monitor the primary AI's output. It consistently scans for strategic anomalies, contextual shifts, and any signature of an adversarial attack. This detects subtle manipulation before a corrupted decision can be acted upon. Finally, layer 3 ties it all together to enable trusted human oversight. It consolidates the data from the other layers into single decision post-decision record for the human operators. The operator can see 3 things: the integrity hash from layer 1 to prove the data was pure, a confidence score reflecting the AI certainty, and a tripwire status from layer 2, a simple green and or red light. This gives humans the verifiable information they need to trust the system. The path forward is to enforce this standard. DIAL is the technology that transforms meaningful human control from a vague legal concept into a verifiable technical process. We propose that policy must require DIAL certification for all future C4ISR and autonomous systems. This certification doesn't just manage risk; it fosters innovation and strengthens our technological self-reliance by building a formation of verifiable trust. To conclude, the future of military AI requires a foundation of trustworthy autonomy. DIAL provides that foundation. It links our ethical policies directly to ethical assurance. It safeguards AI reliability, and it provides robust layered defenses against data corruption. Establishing these principles is the most critical task for all the military AI system are being moved toward 2040. Thank you. By implementation, the AI framework, we move for hoping our AI is secure and proving it. Thank you. If you guys have any question, you can ask.
Sir, hello.
Yes.
So whatever the presentation you are presenting, that has been downloaded from directly from any particular online sources.
It has been researched through many other sources.
So why you have downloaded? You can't do such type of practices.
What?
Is it clear? Whatever the PPT you have presenting here, that is directly downloaded from somewhere.
No. I created it with my own.
No, you have not created, sir. The first thing, as you have to, you are the student, you are the learning phase. So
Yes,
you
sir.
have to, you can take the help of some online sources, whatever the available, make it the modifications. Is it clear? Suppose that if
It is modified.
some of the graph I have made, you can use it, but you have to cite it. Okay, this is not the your work that you have taken from some sources. Is it clear?
Yes, sir.
This is the first time I think you are presenting here. No faculty has been associated with you. That's why you are doing such type of practices.
Yes, sir.
Is it clear? And one thing, this is the first thing. The second thing, what is your conclusion here? What is your findings here that you are going to tell to anyone?
This is basically I was trying to create a centralized AI for military system, but the problems we are facing right now.
I didn't just see. In your whatever the things you have presented it, I didn't get a single point of information from your presentation. That is already from contribution from your side. That is already available in the Google or some sources. What is your contribution?
My contribution is that I try to get as many information from all the sources that I can and integrate it.
Even if I don't think you are able to answer the questions also. Okay, here you have mentioned like data poisoning.
Yes, sir.
What do you mean by the data poisoning?
Infecting data with any malwares that we want to infect it with.
What?
We have a data of a company or anything, any sources, and we want to corrupt the data. We can poison it by finding.
Why you are corrupting the data?
To
What is the need for corrupting the data?
To harm the database or to get data from the company. We can do whatever we want from that thing.
Okay, that is like a malware type of attacks.
Yes, sir.
Okay, then you have used here some you were talking about some case studies or something.
What's up?
You were talking about certain principles at the layer one. You have used certain
Yes,
principles.
sir.
What
Yes.
are the principles? Why I have not mentioned? What are the principles are there at the layer one? What are the principles at layer two? What are the principles at layer three?
I think I told about layer 1, layer 2, and layer 3.
What are the
Quickly.
principles? You were talking about some principles are there, and the principal are ethical guidelines. So what are the principles and ethical guidelines?
In layer 1, I already mentioned that in the data entry tile, we have to measure all the data and verify that it's not been infected at the entry point. That was the layer 1. At layer 2, we were having a, let me, 1 second, please. At layer 2, we were monitoring AI in real time. We were creating a tripwire. That's what that was layer 2. Okay, and for layer 3, we have a human oversight to get layer 1 and layer 2 results and giving it to a person or a supervisor so he can verify whatever the process has been done and to process it further. That those were three of layers, all the 3 layers.
Okay. Okay, ma'am.
Okay. Any other questions? Thank you, sir. Thank you, everybody.
Our next presenter is Khushi Singh. So for Arav Pal paper, since the paper was copied from internet, it gets disqualified from the international conference. And let's move on with our next presenter, Khushi Singh, Tanu Kumari, Sparsh Avi, Abhinandan Kumar, for the poster presentation on the topic AI for social good, bridging technology and humanitarian efforts. Khushi, over to you. 3, 4, 7. Social good.
Good morning, everyone, respected judges and fellow participants. We are here to present our project titled AI for Social Good, Bringing Technology and Humanitarian Efforts. First, moving to the introduction. Artificial intelligence is no longer about automation. It's about using technology to solve real-world problems and improve people's lives. The concept of AI for social good focuses on applying AI to create positive social impact, helping society to become more inclusive, fair, and sustainable. Our study explores how AI contributes to global welfare and supports the United Nations Sustainable Development Goals, such as good health, quality education, and climate action. Specifically, our analysis focuses on 4 key domains: healthcare, education, environment, and disaster management. Now, I would like to explain our study's core idea and methodology. Artificial intelligence has emerged as a transformative force for social progress, driving innovation that benefits communities worldwide. Our study explores how AI enhances decision-making, inclusiveness, sustainability across multiple sectors. We followed a multiple domain approach, focusing on 4 key areas. First, healthcare, where AI uses predictive analytic and medical imaging for early disease detection. Second, education, where adaptive learning platforms make quality education more accessible for all. Third, environment, where AI helps in climate modeling, pollution monitoring, and promoting environmental sustainability. And finally, disaster management, where real-time AI system assist in early warning, rescue, coordination. Moving forward to the next section, where I will discuss about results and discussion. Our study shows artificial intelligence is creating tangible social benefits across several sectors. In healthcare, predictive analytics have improved early diagnosis by 15%. In education, AI-based personalization has enhanced learning outcomes by 20%. In environment, AI monitoring has boosted sustainability efforts by 18%. And in disaster management, predictive system has increased preparedness by nearly 20%. Real-world examples include Google AI for social good, predicting floods, IBM Watson Health aiding cancer detection, Microsoft AI for health for Earth protecting forest, and Duolingo AI for improving global learning access. Now moving to the conclusion. Artificial intelligence has the potential to create lasting positive changes, but only when it is guided by strong ethical principles. Responsible AI means ensuring fairness, inclusivity, accountability in every system we design. True social progress requires collaboration between governments, researchers, communities, so technology serves humanity as a whole. To conclude, AI for social good is not just about innovation. It's about building a fairer, more compassionate world for everyone. Thank you so much. Now I would like to the question section, if anyone would like to ask me.
Okay, what is your title of the paper?
It is
Can you show me?
AI for social good, bridging technology and humanitarian efforts.
Okay, you are making a research paper or newspaper.
No, sir, it is poster presentation.
Poster presentation means what? At least from your side, there should be the contribution. Whatever the things you are presenting here
Yes,
are
sir.
all already available.
Yes, sir.
So what is your from your side? What is the input from your side?
So my only input here is researching about the whole topic
Okay.
and getting
No,
all the
just see
information I
here.
can. Yes, sir.
One thing, whatever the images you have used here,
Yes, sir.
okay, that is not your own images. Have
Yes,
you
sir.
drawn those images?
Oh, sir.
Means you have copied from somewhere.
I have yes generated it,
Okay,
but
so
it is visualized.
have you given the citation for them?
Uh, no,
Hmm?
no,
Okay, do you know the 420 case, forgery cases? Eh?
no, sir.
So this is a 420 case, ma'am. If you are using the images or something from somewhere, you have to cite them. You have that is the role of that. What is the role of the why we are citing? Mean this is not your work that you have copied from this source.
I have not copied. Actually, I have
You
generated
have,
it using AI. The
AI is not AI is not yours. AI is also generating the images from certain sources. Okay, the first thing. So, and here you are applying the AI. Everybody knows AI is getting applied everywhere,
yes, sir.
even in smart devices and all the things. You have to go for the area specific. Like here, you are talking about the healthcare.
Yes, sir.
Healthcare is itself is a very, very vast area.
Yes, sir.
There are so many small, suppose healthcare. In healthcare, there is one part that is a disease diagnosis. In case of disease diagnosis, also there are n number of disease to diagnose it. Suppose if I'm going with the malaria detection, I'm going with the diabetic detection, I'm going with the corona detection. So each are having the different scenarios and different methodologies getting applied for it.
Yes, sir. But
So you
since
have talked about the generalized things.
since it was poster presentation, so it has to be
In case
according
of
to the resolution and the
in case
rules.
of poster, just see whatever the presentation is there,
Hmm.
whatever the presentation is there, every presentation, at least there should be a small contribution from your side. That has to be reflected something like this. You tell me what is the contribution for your side.
So collecting data and putting it in one manner
Huh?
is what I did.
Contribution in terms of like this. What? Collecting the data from? Okay, this presentation is over. Let it be, but next time onwards, be clear about it. If you are going for certain presentation, so in that particular presentation, there must be something reflection that this is your contribution.
Okay, sir. Sorry.
You have consolidated data from the various sources and you have accumulated it. And after the accumulation, this is the finding from your side.
Yes, sir. Thank you.
Is it clear?
Yes, sir. It is clear.
Clear, ma'am, or not?
Yes. Yes, sir. It is clear.
Okay.
Thank you.
Okay, ma'am, I'm done from my side.
Okay, sir. Thank you. Next presenter is Sonu Kumar and Raj Mishra for poster presentation on the topic of AI safety and risk mitigation. Sonu.
ठीक है Good morning, everyone. My name is Sonu Kumar, and I am I am a student of computer science. Today, I am going to present a very important topics: AI safety and risk management. First is introduction: artificial intelligence AI transforming industries through automation and prediction and intelligent decision making, and AI system because more powerful, concern about the safety and ethics and reliability, and increasing ensure AI operator securely and aligns a human value and initial prevent intended harm. Next is what is AI safety? AI safety ensures the artificial intelligence act reliably, ethically, and securely in all conditions. It focuses on trustworthy AI, fairness, transparency, and controls. And next is key risk in AI system. Bias and discrimination. AI trained on basic data can make unfair decision. Data privacy breaches. Sensitive data may lack on be misused. Autonomous system risk. Self-driving and automated AI can malfunction. And next is risk mitigation strategy, ethical AI mainframe, robust and testing automation, and human in the loops and explanation AI, data protection, and AI governance policy. Next is conclusion. AI has the potential uh, to greatly enhance human life, but only developed and devolved responsibly, continuous monitoring, testing, and ethically evaluation and vital for maintenance AI safety. Collaboration between research, policy maker, and developer ensure balance and fair AI system. Thank you.
Sir, whatever the suggestions I have given to the previous two presentations, same thing also, you have copied everything from the chat GPT.
Yes, sir.
Why? Do you know this is the crime? This is the criminal offense. You can't copy anything from any source. Huh? Okay, you can take the help of ChatGPT or whatever the online sources are available. Try to make it modifications on that. Directly don't use that particular statement. Each statement you have copied.
Next, better.
Suppose that if you are going with this type of thing, or somebody has accepted you, or whoever the author of that one, after awarding your degree will be cancelled. That much criminal offense is there. Who is ever the collaborator with you? All degree will be collapsed, will be cancelled. Is it clear? Suppose that this is you copied from the chat GPT. Make certain modifications on that. Have you studied also something here?
Yes, sir.
Okay, tell me what are the principles you are talking about? Still, AI governance policies. What are the policies are there? Tell me any one policy. Here you have written AI, it focuses on the trustworthy. AI fairness. What do you mean by the AI fairness? Tell me how you can check the AI is making some fairness. Tell me any example for it.
Yes, sir. I have no idea.
Then Have you met with any faculty? You are the student. I know that you don't know much more about it. So before presenting, you have to show to your faculty advisor. Have you shown it? I don't think you have shown that particular thing. You take the help from the seniors. Hmm?
Next time should do better.
Okay, so don't copy anything from any source.
Yes.
For the knowledge acquisition, you can use it. But for presentation, you don't use it. Okay, still if you are using, make the citation. This is the thing I have copied from here. If you are not citing, that is known as the citation. If you are not citing, that is the criminal offense.
Sorry, sir.
Okay.
Thank you, sir.
I would like to call our next presenter, Ms. Anupriya, on the topic of instance-based morphological analysis of Maithili language, bridging low resource NLP with computational linguistics. Ms. Anu, over to you.
A very good afternoon to one and all present over here. A very good afternoon to you as well, sir. I would like to introduce myself. Myself, Anupriya. I'm a research scholar from Jharkhand Rai University. And right now, I would like to present my paper. The title of the paper is Instance-Based Morphological Analysis of Maithili Language, Bridging Low-Resource NLP with the Computational Linguistics. Coming forward, I would like to introduce my paper. First of all, coming to NLP. NLP is Natural Language Processing, and this paper is about Maithili language, which is a very low resource language. The challenges for this paper, actually for my study, was there was a very limited annotated corpora. The corpus was very limited. There were lack of linguistic tools, and coming to a very positive point, Maithili has a very high morphological richness. So my goal for this paper, when I'm still working on this paper, and the goal was to develop a morphological analyzer for the Maithili using IBL, that is instance-based learning. The motivation for choosing this paper and this topic for my PhD was, since Maithili is a very low resource language, but it is highly spoken. Approx 35 million people, more than 35 million people are speaking this language, and it is still under respondent. So I am trying to work on this language and to create a paper which can help this language to create further resources online and to create a chatbot and create POS, morphological analysis, and sentiment analysis as well. The morphological analysis is a very prerequisite is a very prerequisite, and it is essential for POS tagging. So the research objective was to build a morphological analyzer for the Maithili language. And for this, I have applied IBL, that is instance-based learning, for further POS classification, that is parts of speech tagging. The related work was done as such. In my previous paper, I had achieved an accuracy of approximately 70%. And right now, I am trying to create a corpus which was actually this corpus has been sent to me via LDCIL. LDCIL is a site, is a governmental site, and I have registered there. I have subscribed them, sent a mail, and I have got few of the data sets, and right now I am working on those data sets. The sentences which I have created right now is approximately 1,000 sentences, out of which only 200 sentences has been correctly used right now in order to create this paper. out of these 201 sentences, 402 words were found, in which I actually instantiated 202 unique tokens. The average words per sentences was 2, and there were few common patterns which I found, which is a very important part of the morphological analysis. That is, there were frequent numerals and frequent particles. The dominant vowel suffixes was akar and ikar, which is you can say a very basic part of the Hindi language, or a script which the Mathili uses, which is Mithilashkar script. There were certain pre-processing steps which I had to follow, such as we had to clean the data and the normalization. After that, I tried to create tokens for the Devanagari patterns. There were removal of the punctuation symbols, and then I tried to extract the characters. There were certain words which were very frequent, and then there were co-occurrence patterns as well. All these were cleaned, and after cleaning all these different sentences, I had created an Excel file for which that was actually the major data set I had been actually working upon. The key morphological features for these tokens generated were there were certain suffix patterns. There were class indicators. I mean, the tokens which were created were having certain gender specifications and the tense makers. There were certain token which were having contextual parts of speech tagging, such as you can see, if there is a word which is ending with akar, you will consider it as a verb maker or mostly as a masculine word. And if it is ending with ikar, I will be considering it as a feminine word, or it can be an inflection indicator as well. Now, coming to my approach, which I had used, that is an instance-based learning. This is also called as lazy learning because it is, it can be working on the data which is given as an input from my side. So it does not rely on any of the linguistic rules, and it stores instances and classifies based on the similarity. These are the certain steps which I had been following while I was doing work on this paper, that is loading and pre-processing the corpus which I had created, tokenizing and extracting the features, comparison of the new words and the stored instances, computing the similarity, and then predicting the POS tagging. Certain evaluation matrices were used, such as accuracy, precision, recall, F measure, and the RSC area. And these are the results as far as I have been working on these 201 generated data sets right now. I have more than 800 data sets still remaining in my dictionary, and these results may vary according to the data when I will be working on them as well. So the analysis part of this work done till now is we have a very strong morphological regularity when it comes to the instance-based learning. The higher ROC shows a good class separability, and the performance is limited right now. The performance is limited for the adjectives, postpositions, and due to data sparsity, since as I told you, Mathil is a very low resource language, so there is a very minimal rule on which I can depend. The discussion, when it comes to the discussion, as far as my paper is concerned, it is somehow related. It is actually majorly related to the I case, and it reduces reliance on the handcrafted linguistic rules. So I am creating my rules, and I'm trying to work on those rules to create tokenizers, parts of speech tagging, so that I can work on my next objective. There is a high semantic richness as well as the morphological analysis. Right now, I have done is I can say that Mathali has a very rich morphology. It has a very rich architecture. The conclusion for my paper work or my work which I have done till now for this objective is that it is providing a viable morphological analysis, and it is working efficiently even for the limited data, and it is capturing an essential suffix based morphological patterns. There are a lot of future work as well. Right now, the first part is I'll have to expand my data set size. I'll be applying various deep learning methods as well. Right now, I'm working with the very basic methods. we can be the first part which I'll have to do right now is I'll have to complete my POS tagging, stemming and passing. These are the certain references out of which two are my papers. Sorry, one is referenced here, then the other one has just been published. It has not been referred, but I've used my paper for references. And the conclusion is still not very accurate, but the accuracy precision done till now are given in the results summary. Thank you. That's it from my side. Any questions from anyone?
Okay, ma'am. The first question is, are you comfortable with the Mathili language?
So it is not my native language, but yes, I have tried a lot to learn it. Right now, I'm a little bit comfortable, not very comfortable with it.
The first thing is that if you are working on that particular language, you have to be confident on that particular language. Then only
Definitely.
you can sense, whatever actually here you are generating the data set by yourself.
Yes, sir.
Okay, so you don't know the word meaning.
So at the
If you're
very
not
initial
good,
stage, it was really very tough. Right now, I'm somehow having a lot more knowledge than before, and at this point of time, I can be telling you the exact meaning of what that Mathali sentence is telling, or even I can talk in the Mathali language
okay, I
to
don't
some
that
extent.
okay, that I don't know how much you know, but that is my suggestions. Okay,
Yeah,
so
sure.
first you have to be comfortable with that particular language, then only you can sense the meaning of that, because there is
Definitely.
a word sense disambiguity.
Yeah.
So whatever the word I am using, that a particular word, a particular word is having the different meanings.
Yes, sir, definitely. Each and every word, it is also depending upon how you are actually pronouncing it. That
Okay, the
also has a
first
different meaning.
that is the first thing. The second thing, as the no literature and nothing, very less literature, as very less data sets are available in the Mathali.
Yes,
So
sir.
for Hindi, so many work is already done.
Yes, sir. Hindi, we have a
Okay,
lot
so
more
so
literature.
so first you compare the what is the similarity between the Mathali language and Hindi language?
Uh, sir,
In
if you
what
come to,
sense? In what
sir,
sense that is the similarity?
sir, actually, there are two different scripts for the Hindi and the Mathili. Hindi, we have Devanagari script. Everybody knows that. For Mathili, the very basic script is Mithilashkar. Right now, when we come to the basic point, Mithilashkar script is somehow extinct. So these days, Mathili is considered as a basic part of the Devanagari script, which
Oh,
is not very accurate according to the
no.
language. So Mithilashkar script is having a relevancy of approximately 60% with the Devanagari script, which is why we consider it as a you can say relevant script with the Mithilashkar, and we say that Mathili is somehow related to Devanagari script. So Hindi is actually relevant. 60-65% of the relevancy is there, but it is not 100% relevant with the Mithilashkar.
Okay, then you can go ahead with for the Hindi, whatever the for a specific thing, whatever the approaches people have worked, and they might have cited that one also. What is the problem with this particular approach?
Yes, sir. There are a
So
lot of
you
problems.
now you are using IBL.
Huh.
Okay, so instead of using the IBL, you can use that particular algorithm, deploy with your data set, and check it how much accurate models you are getting.
Yes, sir. I'm definitely
Okay.
working on different
Okay, that is the one
algorithms
thing.
as well.
The second thing here, you have taken the word sense, sorry, what? Sentence length, average sentence length.
हाँ, sir. Average
That is,
sentence.
okay, that is a two something.
हाँ, sir. That is 2.0.
Okay,
2.0.
2.0. So you try to extend it by 5 to 6. Because what happens if I'm going with the two words, there is no meaning.
हाँ, sir.
I don't
That
know,
is a
I don't
point.
know Mathali, but in case of Hindi,
हाँ, sir. मतलब
like,
those
like
sentences are very less.
okay,
Actually,
so
that is why the average
suppose
was
that
less.
suppose that I told very good. What is the meaning of very good here? In what sense I am saying this is a very good?
Sir, if in Mathili we say अहाँ के छे अहाँ केमन আছে ऐसा कुछ ठीक है तो there are two different languages which is being mixed. Now, what we have to do is when we are comparing about the morphological analysis, we'll have to morpholize these two languages and we'll have to sort the words, whether the word is belonging to Mathali or not. And after that, only we can compare for the morphology of the word. Since aha is a Mathali word that will be used here, but Kemon is a Bengali word and Achi again is a Mathali word. So aha Achi will be somehow an average Uh,
you forget about the Bengali word Assami, because Hindi also so many words are there. First, you focus on that particular what are the purely mathly words.
sure, sir.
Then you can go ahead with some another words also. Yeah, it joins whatever the neighboring states are. That word can be like Hindi. So many words are common, which some of the Urdu words are getting also utilized in Hindi. Is
Sir.
it clear? Some of the English words are also getting utilized in Hindi. Some of the Hindi words are getting utilized in English.
Yes, yes,
Okay,
definitely.
so they have diverted from here. So that depends upon the popularity of that particular word.
Okay, sir.
Sometimes we are using certain words that is a meaningless,
Yeah.
but that also we are using in our common language. So you now you are at the initial phase. So forget about it. First, you focus for the core words.
Okay, sir.
Okay,
Yeah.
now here you are using HMM.
Sorry?
HMM. You have used the HMM also?
No, sir, I have not still used HMM, but that will be used. You
Okay,
can
so
say yeah.
actually HMM is getting considered. So up to how many how many instances? Sorry, how many characters you are going to consider it?
So approximately 1,000. Right now it is
The
402.
consecutive words, like suppose that good. I'm saying good.
Yeah.
Okay, so just you are considering only one prefix. Very good.
Okay, yes.
Okay, before that also, because what happened, the word meaning can be clear. Suppose if you are considering only two words, sometimes the meaning is not getting clear. But you consider the consecutive five terms, five words, then the
5 words
meaning
making
of
a sentence.
the five consecutive words, then only the meaning of that particular sentence may be clear.
Yes, sir. Definitely.
So HMM, that's why I asked, in your PPT you have mentioned HMM.
Sir, I'll be
Okay,
using it in near future as well. That is why I've mentioned it here.
okay, okay, ma'am.
Thank you, sir.
Thank you.
Any more questions? Thank you, sir. I'll be surely working on your suggestions. Thanks a lot.
Okay.
So we are done with our presentation part of track 5. And as we come to the end of this engaging session, I would like to extend my heartfelt thanks to our chair, Dr. Divakar Tripathi, for his suggestions and for his guidance, and to our esteemed keynote speakers, Professor Manju Khari and Dr. Roshan Singh, for their enlightening talks. A very special thank to all the paper and poster presenters for their valuable contributions, and to the audience for their active participants. Let's give a round of applause to everyone for making this session insightful and successful. For the valedictory ceremony of the international conference is scheduled today by 3 p.m. Don't forget to join the session, and all the participants are requested to attend the session to receive their certificates. Thank you so much, Divakar sir. Thank you so much, Manju ma'am, and thank you so much, Roshan sir.
Okay, thank you, ma'am.
Thank you so much, sir.
Thank you.